Okay.
Also.
Hello, good evening to the European Chainlink community. I'm Kevin, and today we're joined by Zak Ayesh, who is developer advocate with Chainlink Labs, and he will show us today how to deploy connected smart contracts with Remix and the Chainlink Hardhat starter kit. Okay, take it away, Zak.
Yeah, thanks for that introduction. Here, I'll share my screen. Okay. Well, thanks for having me. Excited to be a part of this event. So today I'm going to talk about, go over an intro to Chainlink, what it is, the problems it solves, and we're going to deploy a Chainlink smart contract at the end. So a little introduction on myself. My name is Zak Ayesh. I'm a developer advocate with Chainlink Labs. So you may be asking yourself, what is a developer advocate? A developer advocate is someone who helps engineers and really anyone building with a technology, in this case, the Chainlink protocol, be successful and make sure they have a great developer experience. I've followed Chainlink since 2017. I saw that they were solving, the protocol was solving a very important problem. And this solution could shape the future of the internet and digital agreements as we know them. The community advocate program opened up, and of course I jumped on that, and that's how I met a lot of people. So if that's something you're interested in, I highly recommend joining that. I wrote a lot of blog posts, hosted local meetups, and give talks like this. But eventually I decided I really wanted to kind of contribute not only from the community side, but help developers and help from a technical side. And so, I've been working as a developer advocate ever since, and love it. So today's plan, we're going to talk about what is Chainlink, the problems it solves. I'll go over DeFi and Chainlink and how Chainlink powers the DeFi ecosystem. We'll talk about Chainlink beyond just price data. And we'll go over some resources where you can learn some more. And then we'll go to that demo where we deploy a Chainlink smart contract. All right, so we'll go over what is Chainlink. Before we can dive into just answering that question right away, we have to understand what is a blockchain. A blockchain is a highly secure, reliable, and decentralized network that stores data, exchange values, and record transaction activity in a shared ledger and isn't controlled by a single entity. Now that probably sounds pretty complicated, but basically you can think of it as a database that has been replicated over many computers all over the world. So not one person can control it, and anyone can replicate this database. It's all public. Bitcoin is popularly known as the first blockchain and is one of the most well-known blockchains to date. But blockchains can also run application code. So for example, Ethereum has the EVM, or Ethereum virtual machine, that allows arbitrary logic to be run on top of it. And another concept we need to understand is, what is a contract? So a contract can be defined as a binding agreement between two or more parties, or the legal document itself is what a lot of people think of when they think of a contract. A lot of contracts, well, I mean, if we go way back, started being written on stone and evolved to paper, and kind of where we are today is digital contracts or digital agreements. But essentially, these agreements are now done completely on computers. And whether you realize it or not, a lot of these digital agreements really underpin like almost all aspects of our lives today. Digital agreements are really how we've done contracts for the past decade, from bank agreements to social media to your Netflix account and cryptocurrency exchanges. They all have digital agreements backing them. So as an example, when you sign up for Netflix, you are essentially signing their digital agreement that says you may have access, 24/7 access to stream their entire video library. But you'll notice one kind of common thing among all of these digital agreements is that really all the power behind these executing these agreements is in the hands of the institutions who created them. So another example of these digital agreements is traditional finance or centralized finance agreements. Finance agreements like these they work well in predictable, normal market conditions. But a lot of times when conditions get a little bit more chaotic, they don't always execute in the way that they should or in the way that's best for all of the users that agree to that agreement. So an example you may be familiar with is Robinhood. So if you're not, Robinhood is a trading platform for equities like stocks. Essentially, the digital agreement stated, or was thought to state, that as long as the market was open, any user could come and buy and sell stocks, and that the buying and selling of the stocks would execute at the conditions that they determined. Well, a bunch of users decided to exercise this digital agreement, and they wanted to all buy GameStop stock at the same time. Well, it turns out that Robinhood had some vested interests that incentivized them not to enforce their digital agreement and for all their users, and they ended up blocking their service from users buying the GameStop stock at that time, and despite their digital agreement. So we can't always expect centralized finance to be in the best interest of all of their users, and especially the average everyday user. So income smart contracts. Smart contracts are self-executing digital agreements without the need of a third party to enforce them. Essentially, they are code. They're contracts governed by code, math, and logic. Bitcoin is a very basic form of smart contract, or you can think of it that way. But this contract only allows the transfer and ownership of value. Well, sometime around 2014, Ethereum kind of came around and said, what if we could take these awesome decentralized smart contract properties and allow any contract to be written on top of the blockchain? And today we have many blockchains all competing to allow users access to these awesome smart contract agreements. So today, a smart contract typically refers to code written on top of a blockchain. So what makes smart contracts awesome? Well, smart contracts can be very secure. Once a smart contract is live and is well designed, the chances of a hack can really be minimized as they can get the security properties of the underlying blockchain. Contracts like Aave have been live for several years now and haven't had any issue with hacks. You get reliable and guaranteed execution. So traditional execution needs to be enforced, as we discussed before. Robinhood had to enforce their agreement. And insurance contracts, a lot of times the conditions will be met for that contract, but the contract itself will not be executed immediately. So, after the conditions are met, the contract has to be reviewed, go through a whole complicated process, and it could take months or years for that contract to execute and the proper users get their value that they signed up to get. Third, transparency. Traditional digital or paper agreements can be hidden or hide details away from the users that need to see it the most. An example of this was the 2008 financial crisis. A lot of that was caused because these financial agreements were hiding or obfuscating important details that people needed to know. Smart contracts are transparent by design. Anyone can read them. They can see what the terms of the agreement they're signing up for. And this isn't just set for important users. This is for everyone. Trust minimization. There isn't as much counterparty risk because no parties in the agreement have really any control over that smart contract. It executes automatically based on code. We wouldn't have an issue like the Robinhood GameStop debacle if their digital agreements were written on top of smart contracts. And 5, efficiency. So essentially what we're doing is we're automating the execution of these contracts. And in today's world, a lot of contracts that are digital and paper have large legal teams and large process teams, all to assure that those contracts get executed. And those teams and all that time and all that human labor costs a lot of money and creates a lot of inefficiencies. Well, smart contracts, because they automate all of that, can help reduce all of those inefficiencies and make a more efficient world. So this brings us to the Oracle problem. In order to understand Chainlink, this is the key problem you need to understand. Turns out smart contracts aren't exactly as smart as we would have liked them to be. So smart contracts can only communicate within themselves, within the blockchain itself, and they cannot access off-chain resources. So if that contract depended on conditions that were outside of the blockchain, in weather insurance as an example, and rain, they would have no way to access that data. This is a big limiting factor for smart contract adoption because that limits smart contracts to essentially only token transfers and ownership. So you may be asking yourself, well, why can't I just hook up my blockchain or my favorite public blockchain to an API? Well, the reason is because blockchains by design need to be deterministic. So remember how I said that a blockchain is essentially a replicated database spread out on a bunch of computers around the world. So you can kind of see that in this diagram on the slide. You see 3 computers, they're all kind of coming to agreement on the left on what the state of things are. But then on the right, say we hard code an API into our blockchain, and so they go to talk to that API. Well, perhaps one computer queries the API and gets one data result. And another same node on the network, or a different node on the network, queries that API and they get a different value. Well, now the blockchain isn't coming to agreement on what the value should be. So we need some kind of middleware solution that handles coming to agreement or consensus on what off-chain values should be. So this is called the Oracle problem, or also the smart contract connectivity problem. Thus, blockchains are just not able to connect to outside data sources securely without a middleware mechanism. This is where a blockchain oracle comes in. Blockchain oracle is essentially that middleware. It allows blockchains to interact with the outside world, whether that is bringing data into the blockchain or communicating what happens in the blockchain to the outside world. And they allow the blockchain to keep their awesome deterministic properties that they need to have. But the problem with just any old Oracle design, if it's centralized Oracle, is that we're reintroducing the problem that blockchains were originally conceived of to solve. A lot of those awesome properties of smart contracts were because they were decentralized and there wasn't a single source of failure. So if we introduce a single Oracle that ferries data in and relays data out, you are introducing a single point of failure that kind of defeats the whole purpose of the system to begin with. So enter Chainlink. Chainlink is designed to be a modular decentralized Oracle network for connecting off-chain resources on-chain and for connecting on-chain resources to off-chain resources and systems. So in this diagram, you can kind of see an example of many Chainlink nodes coming to agreement on a price and posting that data on-chain. So by combining on-chain contract code and off-chain resources, we can really take smart contracts to a new level and create what's called hybrid smart contracts. These are really like the next frontier of smart contracts. And we can generalize all of this off-chain work and really allow the Oracle network to do any off-chain computation that smart contracts might need, but do so in a decentralized, secure, tamper-proof way that smart contracts and blockchains really need to preserve their very important properties. They really are, hybrid smart contracts really are defining kind of where our industry is going. And I'm really excited to see what kind of hybrid smart contracts are made in the upcoming months and years. So let's talk a little bit about DeFi and Chainlink and how Chainlink is solving problems in the DeFi space. So if you're familiar with blockchains and smart contracts, you might have heard of DeFi, but if you haven't, DeFi stands for decentralized finance. It's essentially taking the logic of these digital agreements behind all of these banks and financial institutions and putting them as smart contracts so we get all those awesome secure properties. And you can think of financial digital agreements like lending or borrowing, and lending and borrowing or exchanging. Those are all examples of financial smart contracts. So Chainlink's DeFi solution is to take a bunch of the most secure nodes that really exist in the blockchain space and have them come together to form sources of truth around various price data. So financial contracts at their core is price data, and these price data data points exist off-chain. So we need an Oracle mechanism, a secure Oracle mechanism to relay this price data on-chain. For example, Ethereum is not aware of its own price across all markets. So we need some kind of Oracle solution to bring that price data on-chain. This solution is called the Chainlink data feeds. So each node in the network independently gets data from some of the most secure APIs and data sources available. And this data is aggregated and made available on-chain for smart contracts to make use of. If you go to data.chain.link, you can watch this activity happen in real time. And all of the contract code is open source. So you yourself can go verify what's happening in the smart contract. You can go to the Chainlink GitHub and verify the logic that's run in the Chainlink nodes themselves. And the best part is, because all this is open source, they open the tools for anyone to create a data feed utilizing Chainlink. So what makes these decentralized data feeds so important? A secure Oracle mechanism is essential to get secure DeFi contracts. We've already seen DeFi hacks happen a lot more than we'd like to see because insecure oracles were targeted. And this caused users a loss and a lot of money, and in the millions. And that's certainly something we do not want to happen in smart contracts. So DeFi has been growing at an insane pace. A lot of really smart people are working on building the future of finance as smart contracts. And Chainlink is supporting a lot of these top projects. So as an example, you can look at these 4 big projects. We have Synthetic, SushiSwap, Set, Protocol, and Aave, which all utilize Chainlink on the back end to get secure price data. And Aave has as much as almost $13 billion locked in. This data was taken about 2 days ago. So this is always changing, but that's just an insane amount of money. And we certainly don't want anyone who are using these smart contracts to lose money because of an Oracle hack. If you want to learn more about the Chainlink data feeds, you can look in our docs. Again, you can also go to data.chain.link and see these in real time. We'll be discussing using these a little bit more in the upcoming demo. So let's talk a little bit about Chainlink beyond just price data, because Chainlink, as I mentioned earlier in the hybrid smart contract section, can do a lot more. So one popular solution is the Chainlink VRF, or verifiable randomness function. Essentially, the VRF brings provably random numbers onto the blockchain. So you may be asking yourself, why can't I just have the blockchain generate those random numbers? Well, you can, but they will not be secure. So due to the nature of how blockchains come to consensus and all that replication, if you generate randomness natively on the blockchain, it can be gamed, and you may not get that provable randomness that you need. So the Chainlink provable randomness allows us to get randomness onto a blockchain in a secure, provable, decentralized way that allows smart contracts to give the users that need this randomness the guarantees that they want. So a cool application that's come up of VRF and that VRF really enabled was NFTs and gaming. For those who don't know, NFTs are digital collectibles. So you can kind of think of them as trading cards that live on the blockchain. And a lot of these NFTs need to give their users guarantees that they were generated in a provable random way. So you can think of it as when you open a pack of trading cards, usually there'll be a certain percent of chance that you get an ultra rare card, or like a certain chance that you get just a standard normal rarity card. Well, Chainlink can give these users those guarantees that when they are opening that pack, that they actually have those percentages to get a rare card. Another really popular solution is, and a new solution is the Chainlink Keepers. So Chainlink Keepers allows smart contracts to have methods that are run in a decentralized and automated way. You may be asking yourself, well, why can't blockchains just run these methods? Well, actually, blockchains don't have any way to run their own methods. They require an outside actor or user to run these methods for them. So if you rely on a single person to run these methods, we're going back to that same problem of introducing a centralized actor and kind of ruining these awesome properties of smart contracts and blockchains. So the Chainlink Keepers allows us to do this in a decentralized way. Cool application of these is example is like users who are taking loans out on Aave. Aave loans require users to keep a certain collateralization ratio. So to take a loan out, you actually have to deposit currency in and make sure that the value of that currency you deposit maintains a certain value. And if it drops below that value, you can be liquidated and lose all of the money you're locked in. So you can automate the maintenance of these loans. If you feel like your loan is slowly becoming close to being under collateralized, have Chainlink Keepers fulfill adding in more deposit for you automatically and in a decentralized way. So where can you learn a little bit more about Chainlink? Well, our docs are a great place to go. We work really hard on them and are constantly improving them to get the best developer experience. They've recently been made open source. So anyone can look at the docs and make a suggestion or make a pull request on our GitHub. If you go to the docs website, you'll see a little make a suggestion, suggested edit button on the top right. If you see anything that you feel like could be done better, please go in there and click on that. And we'd love to see more community members contribute to our docs. And if you're really looking to go from zero to hero using the docs, I really suggest starting with our tutorials. We have 3 tutorials, a beginner, intermediate, and advanced tutorial. And if you go through them, it really will take you on a zero to hero journey on kind of using the Chainlink protocol to make some really cool smart contracts. Another cool resource is our blog. It's a nice place to get easily digestible articles on what Chainlink is and kind of give you some ideas on how to build some fun Chainlink projects. Which brings me to this very specific blog post, the 77 smart contracts use cases. So if you just like, I know I can build some awesome stuff with smart contracts in Chainlink, but I just don't know what. I really can't recommend more checking out this article. A lot of people have had some awesome ideas that spawned from this very article itself. And it just gives you a lot of ideas on where Chainlink can be used in novel areas. The blockchain space itself and smart contract space really could use more connected smart contracts, and there's still a lot of use cases that haven't been explored. So if you need any ideas, I really suggest checking out this article. And if you do have any ideas, I really suggest going and trying them out and building them, because I mean, you could be the next Aave or Synthetics with billions of dollars secured in the protocol that you make. For those of you that like video presentations like this, you can go to the Chainlink YouTube. A lot of engineering tutorials and developer workshops are there. We also have the Chainlink community YouTube, which I believe this is being streamed on, so you're probably already aware of that. And we also, for any people that already have some developer experience, we have some Solidity and smart contract starter kits that already have Chainlink code integrated in them that you can download and create a local environment for and mess around with Chainlink that way. We'll actually be going over the Hardhat Chainlink starter kit in the demo today. So that brings me to the demo itself. So today we'll be going over Remix and Hardhat and deploying smart contracts on both of these platforms. So you may be asking yourself, what is Remix? I've never heard of that. So Remix is a popular web-based IDE for deploying contracts to Ethereum. So what that means is an IDE is an integrated developer environment. It's essentially a tool developers use that has a lot of other tools built into it to make it easy to deploy code. And Remix is one of these IDEs that can be found online and is used to deploy contracts to Ethereum. This is where we're going to start. So what do I have installed? For the Remix demo, I have MetaMask installed, which is a very popular wallet that is integrated into browsers. So you can just download it as an add-on into Chrome, Firefox, or any popular browser. And within that MetaMask account, we'll need to have testnet ETH, because any important interaction with a blockchain, any interaction that involves changing state or doing any dynamic computation on the blockchain requires ETH to be paid to the miners as gas. So I already have MetaMask, and I've already filled up my MetaMask wallet with some testnet ETH. So let's go ahead and start with the demo, and we'll go ahead and start the demo at the Chainlink docs that I talk so much about. Let me this. Okay, so we're going to deploy a smart contract with Remix, but specifically that smart contract is going to use those data feeds or price feeds that we were talking about earlier. So if you look here on the left of our docs, we have the introduction, the tutorials, an architecture overview of Chainlink, but using price feeds. That's what we need to do. And we're going to use it to get the latest price. So I'll click on get the latest price here. And we come to the page and we see some code examples, Solidity code. Okay, this looks great, but oh, we have a button that allows us to deploy the Solidity code straight to MetaMask or straight to Remix. So that's what we'll go ahead and do. Click on this button. Okay, so we got Remix up. You're gonna see a bunch of stuff. We'll go ahead and minimize that. And if we click right here on this gist, we'll see, oh, price consumer v3. That is the contract that we want to access. So we'll go ahead and click on that. And we'll see that smart contract code that we saw in the docs appear here. So I'll give you a little introduction for those of you that might be a little new to Solidity development or development in general on how these contracts are architected. So here we have the name of the contract, price consumer v3 in this case. And then we have what typically how it's organized, we have what's called the state variables or the variables of the contract. So this is where data can be stored in the smart contract and be referenced later. We then have the constructor, and the constructor initializes the state of the smart contract. So in this case, the constructor is initializing our price feed state variable and setting it to point to this address on the Kovan Ethereum test network. And this address is the ETH/USD price feeds address. Finally, we have the methods. Oops. The methods allow us to interact with the blockchain. In this case, this method gets the latest price, that's what it's called, and is a view method. So this method is only reading data off of the blockchain. When you do read-only operations on the blockchain, it's actually can be done for free at no cost to gas. But if this method was to interact with the blockchain in a more computationally intensive way, such as running a math problem or storing information in state, that would cost gas. All right, so now that you kind of have an understanding of what this contract's doing, let's go ahead and deploy it. Let's get to the exciting stuff. So you're gonna wanna click on this diamond symbol on the left toolbar, the Ethereum symbol, and you're gonna wanna switch your environment to injected Web3. This tells Remix to connect to your MetaMask wallet. So you'll see here, it's showing Kovan as my network. So if you go to my MetaMask, I'm on Kovan. And if you find that you're on the Ethereum mainnet, you can switch your network up here. So I'll switch it, keep it on Kovan. And you'll see here on assets, I already have testnet ETH. I also have some testnet link. We actually won't need the link for this demo. And we'll see that my account here does indeed my account or public key and MetaMask right here. We have it pointed to the price consumer v3 contract. So we'll go ahead and click the deploy button. All right, so MetaMask came up with a notification here. And essentially what this is saying is it's telling us how much gas that this transaction will cost. Because even deploying a smart contract onto a blockchain costs gas. We're adding to the state of the blockchain. Since this is a test net, it's relatively cheap. We don't have to really worry about this too much, but just be sure that if you're deploying and you see this confirmation come up, that you are on a test net, because if you are on a mainnet, it will use actual Ethereum that's in your wallet if you have it. So we'll go ahead and click confirm. And you can see that little pop-up saying it confirmed. And if you go to activity, you'll see a contract deployment. It may say pending if it's still being mined by the blockchain, but it looks like our transaction went through. So if we go down here under deployed contracts, boom, we have a price consumer v3, and it tells you what address that contract was deployed at. Click down here. We see that we have a button to use our get latest price method. And if we click on this, we should, fingers crossed, get the latest price of ETHUSD from the price feed on the Kovan network. So let's do it. Click the button and bam, we got it. Right here as an int, we have the latest Ethereum price, just like that. There's no decimals because it's stored as an integer, but you can imagine after 4 places here, that's where the decimal would be. All right, that's awesome. We got the latest price, but maybe we want to use that price and do some cool logic in our smart contract with it. So to do that, we're going to add a little bit of code to this function right here, or to the smart contract right here. First, we'll add in another state variable. We'll call this state variable ETH price, because that's what we'll be storing in it. And we'll make this public so anyone can kind of read and it's easy to access. Just a note, all information by default is public on a blockchain, but when you see something like internal, private, public, this just is basically saying how easy it is for other contracts to access this information. We want to make it easy, so we'll say int public ETH price in this case. Next, we'll go ahead and remove this method. And instead, we will replace it with a new method. It may look similar, it's still called get latest price, but this method is no longer a view method. So this method will get the latest price, and you'll see in this line here, it'll actually take that price and store it in our state variable ETH price. So this should cost gas to use now because we're mutating state. All right, so we're going to deploy this new one. And before that, we'll go ahead and erase this contract from Remix. Again, once you deploy a contract to a blockchain, it's immutable, it lives there forever. So we're not actually deleting this smart contract from the blockchain or anything, just from the Remix UI. And if you ever want to access that contract again, you can save what's called the ABI, and you have the address right here, so you can save it and always access that contract at a later time. So go ahead and get rid of that so we don't get confused. And click deploy and confirm again. And as soon as this goes through, we should see a deployed contract appear here. Yep, so we got the confirmation and boom, our new contract is here. So let's take a look at it. We have now 2 buttons, get latest price, which is now highlighted in orange because it's not a view only function, and ETH price. So if I click on ETH price now, what do you think will happen? Well, let's see. All right, 0, because we haven't set the variable to anything yet. So it defaults to 0. If we run our get latest price method, we should set that to the latest price of Ethereum versus USD. So I'll go ahead and do that. Click latest price, and indeed, it does cost gas now. So we'll have to confirm this transaction through MetaMask. And we'll wait to see this transaction go through. All right, it's been confirmed. We got the notification. So now, fingers crossed, we should have the latest ETH price stored in our contract. Click on this, and yep, we got it. So now we have this data, and it's stored in this state variable, and we can make all kinds of cool logic that works around that. Something you can experiment with in your own time and just see what you can do with it. And you can make all kinds of cool stuff. So yeah, that was deploying a smart contract with Remix onto the Kovan network. I hope you find that it really isn't too hard. As simple as a button click on our docs, and then you're away and ready to experiment and build on your own. All right, so let's go ahead and move on back to the presentation. Close these, leave remix, the docs. Okay, so our next part of the demo will be deploying with Hardhat. And so what is Hardhat? I mentioned it earlier, but Hardhat is a JavaScript framework that makes it easy to create, deploy, and test smart contracts on a local IDE instead of online on a web-based one. A lot of people that come from a development background are used to building their applications this way. So this just makes it a lot easier for them to do it in a way that's familiar with them. And there's a lot of power to these local development environments. Testing can be automated via scripts, and they're generally just a very powerful tool to have. There are other frameworks like Truffle, which is also in JavaScript, and Brownie for any Python devs out there. But today we'll be doing Hardhat. So what do you need to work with Hardhat and go through this demo? I have an Infura account. Infura is basically a service that allows anyone to access data from an Ethereum node without hosting that Ethereum node themselves. Another popular one is Alchemy. You'll need Git installed. Git allows us to copy code repos off of the internet and put them on our local machine. So we'll be accessing the Hardhat repo on the Chainlink GitHub. You'll want Node.js, which comes with Npm also installed. Node.js is a JavaScript runtime environment for local development, and Npm is a package manager that will let us get our dependencies. And Visual Studio Code, which is an IDE, or the IDE of your choice. Could be Atom or anything else. I just personally use VS Code. So where we will start on this demo is from the Chainlink GitHub, specifically the Hardhat repo. So let's go there. Okay, so you'll see our repo here and all of the code. But really all we need to pay attention to is this little button here. This will allow us to copy this code onto our machine. So we'll copy this URL. And depending on if you are on a Mac or a Windows machine, you'll want to open your terminal or command prompt. And you're going to type in git clone, and you're going to paste in that URL and then hit enter. I've already done this step, so I'm not going to hit enter, but a bunch of prompts will appear. It'll show that it's cloning it, and it should be done relatively quickly. So after you do that, we'll display the directories here. I'm just in my root directory, and we'll see the Hardhat starter kit is already there. Perfect. So now we're going to open that directory in Visual Studio Code or the IDE that you're using. So I've already got this open for us to use. Okay, so this is our IDE. As you see, we have like the same directories and files that we had in the GitHub repo because we just directly copied it. And if you look in here in this directory, you'll see the contracts. Here's that price consumer v3 contract that we deployed earlier, along with the API consumer and random number consumer contracts. There are also folders for Hardhat tasks. These are those customizable scripts that you can really make Hardhat so powerful. You can do just about anything with these. And some pre-built-in deployment scripts to make it easy for us to deploy these smart contracts. And of course, for any developer, some pre-built-in tests to use as a reference point when building your own code tests. Okay, One important thing you'll need to know before using Hardhat, any time you open up a new Hardhat instance or a new terminal with Hardhat, is setting environment variables. One way you can set them up is via an environment file, such as this example here. And this is where you're going to set that Infura or Alchemy URL. You only need one of them to point to that Ethereum node, and put a private key for your wallet. Now, this is important because you want to keep all of this information private. You really don't want to share this with anyone. If anyone gets your RPC URL, they can spam your URL and actually get you banned from those services, or bump you up to where you have to pay. And your private key, if anyone gets a handle of that, they can have full access to your wallet, get all of your funds, see all of your history, everything. So it is really essential to make these private. I've actually already set up my environment variables here, so I won't be setting them, but yeah, it's just a very important step. Next step you'll need to do after setting your environment variables is running npm install. Again, I've already run npm install, so I'm not going to do that, but I'll just install all of the code that you will need, that your smart contracts and Hardhat will need to successfully deploy everything and create a good work environment. Once you run npm install, you'll see this directory here, node modules, that contains all of these packages, including, you'll see the @Chainlink package there. Okay, so we've done npm install, we've set our environment variables. I think it's time for us to deploy our smart contracts to Kovan. So within here, all you have to do is type in npx hardhat deploy. And we're going to want to tell it where we want to deploy it to. Do you want to deploy it to a local network? Do you want to deploy it to the mainnet? Do you want to deploy it to a test net? We want to deploy it to Kovan, just like in Remix. So we'll type in -- network
Zach,
Kovan. Yes.
go ahead, Kevin.
Oh, Zach, you're still only showing your GitHub on screen share.
Oh, really?
Yeah.
Oh, man. I had no idea. Oh, that's odd. Let me see what's going on here. Weird. It should have been my whole window that's sharing. Real quick, let's see. All right, I'm going to stop my sharing real quick and see if I can reshare it. Okay, there. So if I put this, can you see my code editor now, or is it the same?
No, still only the GitHub.
I don't know why it's doing that. Okay, well, I'll just have to share my code editor itself, which I can do real quick. Okay, can you see my editor now? Is it clear?
Yeah, I can see it.
Okay, yeah, sorry about that. I don't know what was going on. I tested that beforehand. But okay, so a quick recap of where I was at and where everything is. So you have the whole repo shown here. We have the contracts, the API consumer, price consumer, all of that. Our tasks are here, scripts we can run, node modules for running npm, all of that's here. So we have a terminal already open right here in our directory that we want to be in, the Hardhat starter kit, and I was just about to deploy. So I was typing in npx hardhat deploy. I put in -- network, that is, so we can point to the right network again, and Kovan. So you guys got me right before I was about to put enter on that. So good timing there. And so we'll go ahead and hit enter. And we'll see it. I had already pre-compiled these contracts, so it says nothing to compile here. It's going to reuse some old deployments, but we successfully deployed. It puts our contracts on the Ethereum Kovan network. And for each of these contracts, it gives us some pre-built-in Hardhat tasks we can run to interact with these contracts. So we're going to do what we did in Remix, and we're going to read the price feed data from this contract. So we're going to copy and paste that command. It's already pointing to that very specific contract instance we deployed. And we're just going to hit enter. And bam, we have the price of Ethereum now showing locally in our Hardhat environment. And again, you could go customize that code in the contract, do whatever you want with it, make tests, do all kinds of cool stuff. And that is the Hardhat demo. So I'm gonna have to stop sharing again real quick and go back to the presentation and share again. Okay, you guys can see the presentation, right?
Yeah.
Cool. So that brings us to the end. And I just want to thank everyone for being a part of the community and coming to these talks. I was a member, just a community member to start with, and I just know how important it is, how important everyone is to the Chainlink project. You guys are really what make this project awesome. And this is an open source project, and we're constantly improving. And any of you can help improve the Chainlink protocol itself. So I know many of you are already part of the community, but if you're not, please come in and join the Discord chat. You'll find me and my colleagues, Patrick and Harry, in there all the time, helping out with technical questions. Feel free to, of course, check our docs and make suggestions there. Like I said, really excited to have those open source. Go to our GitHub and check out the code anytime. And if you want to contribute, feel free to make a pull request or make an issue there. And we're increasingly encouraging people to post any really technical questions you have on Stack Overflow. We have a tag there, Chainlink. So feel free, if you have any Chainlink technical questions, to go there and add that tag, and we should get to you shortly. So with that said, thanks a lot. Thanks, Mark. Thanks, everyone, for hosting this. And again, I really apologize for missing out on a little bit of those terminal commands, but really not too much happened there. So with that, I'll open the floor for any questions anyone may have. I don't know if Mark, they're sending you any questions over the chat.
Hi. No, there is not questions over the chat, but Kevin want to ask some questions.
Go for it, Kevin. Open to anyone.
So, for example, if I'm interested in developing a DeFi app, I can use the Chainlink docs for how to use Chainlink, but of course I also need to learn how to code with Solidity. Do you have some recommended sources for starting to learn Solidity?
Yeah, I mean, there's a lot of really cool resources. I mean, a lot of people have been on websites like Crypto Zombies. That's a really popular starting source into learning Solidity. Ivan on Tech, he's really good. Has some good tutorials. The Solidity docs are actually really cool if they're a little dry. But also, I mean, the Chainlink docs do I think a pretty good job of also being an introduction to Solidity. I didn't know too much Solidity when I first started learning all this stuff, and was able to get through the docs pretty clearly. So yeah, those are all good resources to check out.
Okay, thanks. Also have a question. How is working for Chainlink Labs like? Do you enjoy it? Or?
It is fantastic. I've worked at a bunch of different places before this. My background is actually mechanical engineering. I worked at a couple of German engineering firms. I worked at Wells Fargo as a developer for a bit. And by far and away, this is the best job I've ever had. There's just such a sense of purpose you get when you know that you're building something that could be so important to the future of everything, of agreements, of the internet, and that sense of purpose is just kind of driving everyone in the whole company. And you can really feel it. It's really cool. Everyone's working really hard. And so, yeah, I mean, I know we're definitely going on a hiring spree. So if any of that sounds cool, you can look on our jobs page. You can go on Discord. We have a channel for interested job seekers. And yeah, I mean, I can't recommend it anymore.
Okay, thanks. Also, thanks for the great presentation. Definitely learned a lot today. So
I appreciate that. Yeah, I loved it. It was fun.
Excuse me, Zach. We have a question on YouTube. Is regarding Hardhat. Do you prefer deal yourself with the deployment scripts or using Hardhat deploy?
Hardhat deploy actually uses those deployment scripts I showed you. So that is the backend. We just kind of pre-built those in, so it was easy to use. So of course you could customize your own, but yeah, I mean, go ahead and feel free to use Hardhat deploy. And if you make your own contracts, you only make your own deployment scripts that point to those contracts.
Okay. Thank you.
No problem.
So Kevin, do you want to say something or just finish this meetup?
Yeah, if I think there's no more questions left, then thanks, Zach, for the presentation today, and yeah, that's it.
Hey, no problem. I'm looking forward to doing more of these. Hopefully, you guys will be seeing me more out and about in the community, making some more text.
Just a secret, it's his first meetup.
Yeah.
Hey, not so much of a secret anymore, but
perfect.
Congratulations.
No, congratulations to you, Zach. Perfect. Thank you very much. Thank you very much, guys. So,
right.
I'll see you. Bye-bye.
Okay.
Thank you, Kevin.
Yeah. Thanks, Mark.
Bye.
Bye.